Question number 3 is pretty simple. It just requires that we use Kirchhoff's voltage law or Kirchhoff's loop rule to solve it. KVL tells us that the sum of all of the voltages in a loop must be equal to 0. And so to solve this problem, we're going to pick certain loops from the circuit and set the voltage additions from the batteries equal to the voltage drops across the resistors. Starting with the top loop, on the left-hand side, we have our V1, which is our voltage added to that loop. And then we can set that equal to the voltage drop across the 4 ohm resistor. So we can say V4 ohm plus the voltage drop across the 3 ohm resistor. And if we can remember back to Ohm's law, which is that V equals IR, we know that the voltage drop across the resistor is the current through the resistor times the resistance of the resistor. And so we can just say that the voltage drop across the 4 ohm resistor is equal to 4I3 because the current through that resistor is I3. And the voltage drop across the 3 ohm resistor is just 3 times I1 because you can see that current going through that resistor is I1. And that leaves us with our voltage 1, which is 5 volts, is equal to 4I3 plus 3I1. Let's take a look at the larger loop now. We go around the entire perimeter of the circuit, and let's write out a KVL equation for that. So to start with our voltages, we've got V1, and we're actually going to subtract from it V2 because they're pointing in opposite directions here. As you can see, the pluses are pointing towards each other. And so V2 will be subtracted from V1. So V1 minus V2. And then we can set that equal to the voltage drop across the 2 ohm resistor, which as we know from Ohm's law is just 2 times I2. Plus the voltage drop across the 3 ohm resistor, which we know from the equation above is 3I1. Substituting in some numbers, we can get, instead of V1 minus V2, we can get 5 minus 2, which is just equal to that 3 volts, is equal to our 2I2 plus 3I1. Now we've got 2 equations, but we unfortunately have 3 unknowns. We have an I1, an I2, and an I3. However, if we can remember Kirchhoff's current law, which states that the sum of all the currents going into a node equals the sum of all the currents going out of a node, we can turn those 3 unknowns into 2 unknowns. And the way we can do that is by looking at the junction where all of the currents meet in our circuit, which I'll highlight up top. Highlighter, see it right there. And if we write out a KCL equation, we can relate I2 to I1 and I3 and get it in terms of those 2. So using KCL, we know that the sum of all the currents going in, which is I1, is equal to the sum of the currents going out, which is I2 plus I3. And so by that logic, we know that I2 is equal to I1 minus I3. We can then substitute that in for I2 into our second equation, and we get that 3 volts is equal to 2 times I1 minus I3 plus 3I1. Next, we can distribute this out. So we get that 3 volts is equal to 2I1 minus 2I3 plus 3I1. And that can just be simplified to 3 volts equals 5I1 minus 2I3. Finally, we've got 2 equations and 2 unknowns. And at this point, we can just isolate one variable and solve. You can do this any way that you'd like, but I'm going to start by isolating I3 in the top equation. So I can get that I3 is equal to 5/4 of a volt minus 3/4 I1. Next, I'm going to take that and plug it into our second equation. And that is going to leave me with 3 volts equals 5I1 minus 5 halves. 5 halves of a volt plus 3 halves I1. You can see I distributed out that negative sign to turn the negative in the first equation into a positive. Rearranging a bit further, we can get 11/2 volts is equal to 13/2 I1. We can bring this to the other side and get 22/26 amps is equal to I1. The reason we go to amps there is because we divide volts by ohms. And that simplifies down to 11/13 amps. Next, we can plug that value into our equation above for I3 and solve for that. So we've got I3 is equal to 5/4 of a volt minus 3/4 times I1, and we can substitute in 11/13 amps. Next, we can distribute out our 3/4 and get a common denominator, and we're left with I3 is equal to 65/52 minus 33/52. That leaves us with I3 is equal to 32/52, and that just simplifies down to 8/13 amps. In the final step, we know from Kirchhoff's current law that I2 is equal to I1 minus I3, and so that leaves us with I2 being equal to 11/13 an amp minus 8/13 amps. And finally, we get that I2 is equal to 3/13 amps. And so that is how you solve for all of the currents in this problem. Hope that helped.